Algebra 2, Chapter 15, Section 2, Arithmetic Series. A series is the sum of the terms of a sequence. Okay, this is easy to get confused. So remember, the sequence is an ordered list. A series is a sum of an ordered list. Okay, so sequence is the list, series is the sum. An arithmetic series is a series over an arithmetic sequence. S sub n, big S sub n, represents the nth partial sum, or in other words, the nth series. So S sub n is equal to each of the items in the list added together. And of course we can write this using sigma notation. S sub n equals the sum from I is 1 to n of a sub I. So to understand the general formula for an arithmetic series, it helps us to consider a concrete example. Consider the sequence 1, 2, 3, 4, 5, 6, all the way up to 100. What would be S, not really S sub n, but we'll start by thinking what would be S sub 100? In other words, what is the sum of the first 100 positive integers? So of course we could sit down and add 1 to 2 is 3, 3 plus 3 is 6, 6 plus, and so on. But as legend has it, this same question was posed to a young Carl Friedrich Gauss in the late 18th century. Within seconds, he wrote 5,050 to the astonishment of his teachers. How did he do it? Well, we don't know for sure how Gauss did it, but this is how most people think that he did it. I personally think he had already thought of this before he was asked the question, because I think that he was the kind of person who would think about problems like this just for fun. But I think what he realized is if I take the first thing in the sequence and the last thing and add them together, I get 101. If I take the second thing and the next to last thing, which is 99, add them together, I get 101. If I take the third and then third from last, I get 101. And when I get all the way down to 49 and 50, when I get all the way down to 50 and 51, still 101. So the sums of the pairs as we go from each end towards the middle is always the same. Now how many pairs are there? Well, there's 50 pairs from 1 to 100. So the answer is 50 times 101 is 5,050. Okay, so we can apply the same logic and come up with a general formula for the series n. Remember that series n is the sum of all of the entries in our sequence, but in this case we're talking about an arithmetic only. So look at the title. We're talking about arithmetic series. So in an arithmetic series, when the series is an arithmetic sequence, when the series is of an arithmetic sequence, we take the first thing in the sequence and the nth thing, add them together, multiply by the number of things, and divided by 2. So we could write this even simpler as n over 2, a sub 1 plus a sub n. That is the sum. So we don't actually have to add everything. We just need to add the endpoints, multiply by the number of things, and divide by 2. Also, we can remember from the definition of an arithmetic sequence that the nth part of an arithmetic sequence is the first part plus n minus 1 times d, or d was the distance between the numbers. And then we can get this bigger formula which only uses d and a sub 1, which is the original initial entry in our sequence. Let's get some practice using this formula. To force a company to comply to pollution standards, judges sometimes impose daily fines that increase. Suppose that a judge imposes a $3 million fine on the first day and increases the fine each day by $2 million until compliance is reached. Using sequence notation and expressing the daily fine in millions, find S sub 4, the total fine after 4 days, and S sub n, total fine after n days. Well, S sub 1 we know is $3 million the first day. On the second day, it's the 3 million, right? Plus 3 million more, 2 million more than 3 million, plus 5 is 8. Okay, so if you think of the A sub 1 is 3, A sub 2 is 5, right? This is the arithmetic sequence which represents the fine on each day. Okay, but what we're interested in is the total sum on each day, because we had to pay the 3 million and the 5 million and the 7 million on day 3. So day 3, it's day 2 plus 7, 15 million, and day 4 we would have the 15 from day 3 plus 9 more million, which is $24 million. Okay, so now we can, and this is quadratic growth of the actual sum, right? And we see that by the formula. We have our sum, which has an n in it. If you think about this formula, it's quadratic. You have an n times an n. Okay, so this is not linear growth. When we take the fine and increase it every day, the fine is growing linearly, but the total amount of money we have to pay is growing quadratically. So if we think about that, S sub n is going to be A sub 1 will be 1/2 times n times A sub 1 doubled. Going back to this formula here, plus n minus 1 times the distance between. So it grows by 2 million each day. Okay, so then we can get a formula using some simplification. 6 plus 2n minus 2 by multiplying the 2 here. 1/2 n 4 plus 2n. And we can go ahead and multiply the 1/2 n out, and we would get 4 over 2 is 2. 2n plus 1/2 n times 2n would be n squared. Assuming we did all of our arithmetic correctly, we should be able to test this, but looks like, well, let's just try it. So if we put in 1, so S sub 1, put it into our formula, we would get 2 times 1 plus 1 is 3. Put in 2, we would get 2 times 2 plus 2 squared, which is 8. Put in 3, we get 2 times 3 is 6, plus 3 squared is 9, gives us 15. Put in 4, we see 2 times 4 is 8, plus 4 squared is 16, is 24. So you can see it matches what we found here. So for our first part of the question, the answer is 24, is S4. And the second part, the answer is 2n plus n squared is the total fine. So now it's clear that it's how it's quadratic growth. The longer we wait, we have to pay more and more money. Write the sum of the first 17 positive even numbers in sigma notation. Okay, this is going to be helpful to think about writing this out. Positive means not 0, so it's to be 2 even, is 2, 4, 6, 8, 10, and so on, all the way to the first 17 positive even numbers. So this is the first, second, third, fourth, fifth. So 20 would be the 10th, and 30 would be the 15th. So it should be 17 times 2 would be 34. Now is that the 17th or the 16th? So if we think about if this was just for the first 5 numbers, we would have 5 times 2 is 10. So this is the 17th. Okay. So now what we need to do is use our we didn't really need to know that because we could use this formula that doesn't use the n number. But if we want to use the formula that uses the n number, it's a little easier to remember. S sub n, actually in this case we know n is 17. S sub 17 equals the sum in sigma notation of I is 1 to 17 of a sub I. Okay, and we can write the a sub I. We know how to find a formula for an even number. It's just double whatever our index is. So if it's I is 1 to 17, we can write this as double I. Okay, that would be the answer to the first part. For the second part, we can use the formula we know for series, for arithmetic series. It's 1/2 n, which is 17, times the sum of the endpoints, so 2 plus 34. Okay, and if we didn't know that, we could also use the other formula, which would be 1/2 n double a sub 1 plus n minus 1, which is 16, times the distance between them, which is 2. And these should come out to the same thing if we got this right. So let's do the bottom one first. 16 times 2 plus 2 times 2 is 4 is 36. So in both cases we get 36. We can do it either way, get the same number. So 36, and I'm going to go ahead and take the divide by 2 is 18 times 17. 306 is the answer. So the sum of the first 17 positive integers is 306. And we didn't have to actually add all 17 of them. In fact, and we didn't even have to find 34. We could have just used the second formula and not even bothered finding a sub 17. Evaluate using the formula for arithmetic sequences the following sum. The sum from 0 to 10 of 2 plus 1/3 n. Okay, so this looks a little bit hairy. How can we do this? Okay, so if we remember the sort of general formula, S sub n was 1/2 n times 2a sub 1 plus n minus 1 times d. Okay? And if we remember the general way the summation looks, S sub n is the sum from 1 to n of a sub I. Okay? And we can define the a sub I using the formula. Remember, a sub n is a sub 1 plus n minus 1d. So we can make a sub I equal the sum from I is 1 to n of a1 plus I minus 1 times d. Okay? So here we have a sum, and we're going in our, we could call ni, it doesn't matter what we call this index, okay? So here this is a little confusing because this n means this 10, okay? So if we could just change these n to something else to help us out, let's pick k just for fun. Okay, we'll just make that a k. So no more n, let's think of it as k. Okay, so we have this index k. Here's the index in this sum for this arithmetic sequence. The problem is our indexing starts at 0 instead of 1. And we don't have k minus 1 like we have in this formula. So we need to take this sum and split it up. So if we have the sum, we could think of the sum as 2 plus 0 plus, that would be the 0th term. For 1, we'd have 2 plus 1/3, which is 7/3. And then for 2, you'd have 8/3. And for 3, you'd have 9/3. All the way up to when you had 10, you'd have 10 times 1 is 10/3. plus 2. 2 is 6/3, so you'd have 16/3. Okay? Now, we could just take this piece and leave it as 2 plus and write this with the sigma notation. And we would just write sigma as k is 1 to 10 of 2 plus 1/3 k. And if we just add 2 to this sum, then we get the same thing as this original sum. And now we have our indexing right. Okay, so I just messed up here. So it's not 2 plus here, it's 7/3. Right, because we now are starting at 7/3. But our d is the same. We didn't change the d. Now the problem is k here is not k minus 1, so it's just, and I think I messed that up, this is still 2, because it's built into this, watch. When we think about evaluating when k is 1, we have 2 plus 1/3, which is 7/3. When we have 2, 2 plus 2/3 is 8/3. This is just 2. Sorry, I got confused. I didn't mean to confuse you. What's changed is our index is now 1. We're taking the first thing out. Okay, so we took the first thing out. The 0th entry is 2. Took that out. Now we have just a summation plus 2. Okay, and this summation looks a lot like this sort of generic one. D looks like it's 1/3, but our index is at minus 1. So what we could do to fix that is we could add a third. Sorry, let's do it this way. Subtract a third and add a third. And that doesn't change the value of any expression because that just adds to 0. Now if we think about factoring that third, I chose a third so we could factor out and get k minus 1. We would have 2 plus k, sigma k is 1 to 10 of 2. And I'm going to move this 1/3 over, 2 plus 1/3, and then factor out the 1/3, k minus 1/3, and get 1/3 times k minus 1. Because I pull this 1/3 out and this 1/3 out. So this plus 1/3 I moved over to add to 2. And then these two terms I group, and I take the 1/3 out. I'm left with k minus 1. And 2 plus 1/3 is 7/3. So now this is what I want it to look like. Now I can easily identify an a sub I. This matches and a d. Okay? So now I can find this sum using the formula. So the formula was s. Here's the formula. So s sub 10, so we want to find 2 plus s sub 10, because 2 had to be added because this indexing is at 0. So 2 plus s sub 10. Now I need to find this. So s sub 10 equals 1/2 of n, which is 10. So 10 over 2 is 5. Times 2 times a sub 1, which was the 7/3, times 2. I switched the order of that. Let's make that less confusing. So 2 times 7/3 plus n minus 1. 10 minus 1 is 9 times 1/3. Okay? That gives us 5 times 14/3 plus 9/3. 14 plus 9 is 23. Thirds. Which is not divisible by 3. So we have 9. 2 times 7 is 14, plus 9 is 23, times 5 is 115. And of course that's not divisible evenly by 3, so we can leave that as 115 thirds. And then adding 2 to that, we get our answer. 2 is 6/3, so it would be 121 thirds. Or if we wanted to split that into mixed fraction, it would be 40 and 1/3. as the sum of the first 10 plus the 0th one. So that's how we can deal with this indexing by 0, which may come up in your homework. Just another comment about that. I probably won't do the indexing by 0 on the quiz or test, so I see it as kind of just a little corner case, but it does show up in your homework. So here's how we can deal with it. So just real quick, just going back over this, what we did is we pulled this first entry out so that we get the summation from 1 to 10. Okay? And then we did this trick of subtracting and adding to get k minus 1. So we can match it up with the general formula of an arithmetic sequence. Once we have the arithmetic sequence identified, we know what a sub 1 is, we know what d is, and we can apply the formula for an arithmetic series in order to find the sum very quickly of the first, this time it's really 11 things in the series because we're going from 0 to 10.